So once again, my name is Pax Haymeyer. I'm the Director of Programs here at SCPD, and it is my pleasure to introduce Neil Deswani. He is a co-director of the Stanford Advanced Computer Security Program, and computer security is kind of in his DNA. He's served in a variety of research, development, and executive roles at companies including Symantec, LifeLock, Twitter, Dacient, which he founded, Google, Docomo Labs, Yodlee, and Belcore. Indeed, he was the Chief Information Security Officer at LifeLock and at Symantec's Consumer Business Unit. He is also an accomplished educator. So as I mentioned, he's worked with us on the Stanford Advanced Computer Security Program here at the Center for Professional Development. He's also authored a book on the foundations of security, what every programmer needs to know, which is excellent. And he's working on a new book on big breaches. So he's got quite the resume to talk about these issues. Today, he's going to be sharing some of his insights on some recent cloud security breaches and some ideas about how to mitigate them. So with that, I am going to turn the presentation over to Neil. He is going to stay off camera. As you know, in these times, it's hard sometimes to find a setup that works well. So he's going to stay off camera for right now and we'll focus on the content.
Great. Thank you very much, Pax, for the introduction. Hope everyone can hear me okay. Today, I'm going to be talking about lightning in the skies. I'm going to be talking about some cloud security breaches, and I will chat a little bit about how you can start to mitigate them. Of course, there's only so much that one can cover in a, say, 1-hour webinar, but I hope that you'll find the information here about some breaches in the cloud and steps that you can take interesting. So let me just go ahead and get right into it. As many of you know, cloud services have been seeing great adoption over the past 10 plus years. And I would say that as with any platform, as soon as it starts to achieve significant prevalence and footprint, security problems usually start coming up. So I'd say that some of the lightning in the skies started back in 2017. What happened in 2017 was that some attackers used a set of scanners to scan pretty much the Amazon Web Services AWS IP space. And they found that there were tens of thousands of unprotected MongoDB databases. MongoDB is a semi-structured NoSQL type of database that developers have been adopting over the past several years, given the growth in non-relational data. And so starting in late 2016, early 2017, there were over 10,000 attacks that got recorded where, because of the fact that a lot of MongoDB databases were being deployed with insecure configurations, insecure default configurations, out of the box, it would get installed, and it would allow for communication to the Mongo database on a port 27017, which is the default port for the database, and it would allow in unauthenticated connections. And so, while that may be when someone's experimenting or developing a new application, one can imagine that somebody might do something like that, but it is really important to put appropriate authentication and other types of controls. And so, what happened is there were a whole bunch of attackers where what they did is they took control of the databases. They were often accepting unauthenticated communication. They were running with full admin rights. And so what the attackers did is they cut off access to those databases and said, you must pay me a ransom in the form of Bitcoin if you want to get access to your database back. And so here on the right-hand part of the slide, you can see an example tweet about some of these attacks and the Bitcoin ransoms. There were more than 17 ransoms paid, but that's kind of a lower bound. Bottom line, root cause is that there were a whole bunch of people deploying Mongo databases on AWS with insecure default configurations. The steps to mitigate these sorts of things are pretty simple. Let me mention, though, that in these ransomware attacks that took place at this time period, one of the things that was interesting is that for those of you that are familiar with ransom attacks, and if you're familiar with malware that has been used to conduct ransomware attacks, say against desktops, PCs, or other types of servers, very often what the attackers will do when they deploy the ransomware is the ransomware will encrypt the data and basically ask for a ransom for the decryption key, so that only when the ransom is paid can the data be decrypted. Now, in this particular case, because full admin rights were accessible on the database, the attackers didn't actually even really need to encrypt all the data in the databases. They just needed to cut off access, and then could give access back once the ransom was paid. So in any case, to mitigate these types of attacks, there's 3 simple steps that you can take. One, use secure defaults instead of insecure defaults. And after these incidents, both Amazon as well as MongoDB just started making a whole bunch of more information available to folks so that they could configure their databases in a more secure way out of the box. So an example of using secure defaults is to require that connections be authenticated, require that the person trying to connect into the database present some identity credentials. And you make sure that you actually know who it is, as opposed to letting any random Joe that can scan IP space, the internet and Amazon to connect in. Secondly, limit privileges. While some databases might come out of the box accessible via admin user or root passwords and whatnot, there's no reason that users need that level of privilege in order to regularly use the database. So you could basically not allow full admin rights, configure certain database rules based on what the person needs to do. And by the way, this concept of limiting privileges down to what privileges people need to do their job, this is actually a pretty consistent theme that you'll see as I talk about some other breaches as well. The third key mitigation is that given all the important data that might be in a database, whether it's on the cloud or otherwise, it's important to make sure that it is regularly backed up. For any kind of ransomware attack, whether it's a cloud-based ransomware attack or a ransomware attack against laptops and PCs, effectively, if you have good backups and say you've backed up once an hour or once a day or something like this, if an attacker comes in and takes control of your database and you don't want to pay their ransom, if you have a backup, you can just restore the backup. And sure, you'll lose some perhaps recent transaction activity or whatnot, but your application won't be completely unavailable, and you won't completely be at the whim of the attackers if you have good backups. And so, since then, MongoDB has published a lot more information about how to do good backups. MongoDB has tools like the MongoDB Cloud Manager and the MongoDB Ops Managers, and they actually allow for continuous backup. So every transaction can be backed up, and you can get back online fairly easy. So this is information on the MongoDB ransomware attacks. Also in 2017, there were a whole bunch of attacks where, there's different resources in any cloud computing platform. And so, very often the cloud computing platform will make available virtual machines so that you can run your workloads in a segregated environment. Most cloud platforms offer some form of storage. And so if you need to store a lot of data, Amazon provides a service called an S3 bucket, a simple storage service. And what happened in 2017 is that a whole bunch of organizations that were using Amazon's S3 bucket storage ended up getting exposed and compromised because the default settings for the storage buckets was public by default. And so if you look at this table here, you'll see that there's been a whole bunch of entities that were breached. Defense contractors like Booz Allen Hamilton, U.S. Voter Records, Dow Jones and Company, Verizon Wireless, the Pentagon. And in each of their cases, they had different data uploaded into the cloud, into these buckets. You can see from the table that the data was very sensitive. Battlefield imagery, personal data about almost 200 million voters. The Pentagon had terabytes of information from spying archives, and these data sets ended up being publicly accessible because these organizations had not configured their Amazon S3 buckets to be private and as locked down as they could have been. And in fact, later in this webinar, I'll show an example of an S3 bucket configuration and talk about public and private settings. I will mention that since a lot of these incidents back in 2017, Amazon has taken some very, very significant steps to help people make the right secure by default configurations here. So let me chat about a next cloud security breach. So the next cloud security breach that I want to talk about is the Capital One breach that took place just last year. In this particular breach, there were over 100 million consumer credit card applications that were stolen. These applications had social security numbers in them for U.S. applicants. They had the equivalent of a Canadian social security number in them as well. This particular attack was conducted by a lone hacker who used to be an Amazon employee by the name of Paige Thompson, or codenamed Erratic. And, the impact was quite significant. As opposed to most breaches these days, which are conducted by organized cyber criminals or nation-state adversaries, this particular attack was, as I mentioned, done by a single lone person, a former Amazon employee, and she was caught fairly quickly, given a $250,000 fine and 5 years in jail. But the impact to Capital One was much more significant. This breach costed Capital One over $300 million. And so, while that seems like a big number, right, given the number of records that was stolen, over 100 million, it's about $3 per record. So, it's not a lot per record, but overall it sums up quite a bit. How did this breach happen? And actually, I'm going to walk through a set of technical diagrams showing exactly how this attack was done. But at a high level, they had a firewall misconfiguration that allowed Erratic to access the Amazon S3 buckets that were used to store the 100 million credit applications. There was also a virtual machine that had a vulnerability called the server-side request forgery vulnerability, which I'll also talk about. But that's pretty much how the attack was able to be technically executed. It could have been prevented through perhaps more rigorous firewall review. It could have perhaps been prevented by some automated cloud security scanning. And so one of the things to keep in mind about cloud services in general is that, especially at this stage, they make a lot of features and functionality available to their users. And there are hundreds, if not thousands, of configuration parameters. And in order to achieve security, all the relevant ones need to be set exactly right. If there's even one that's off, then it may give an attacker the ability to get an initial foothold into an environment. So with that, let me go ahead and talk a little bit about some of the technical details of how this particular cloud security breach occurred. By the way, I think the Capital One cloud security breach, at its time definitely was the largest cloud security breach. That's true even today. Of course, we seem to live in a world where there's a new mega breach every month, so we'll see how long it retains this record. But in any case, let me talk about the Capital One breach. In this diagram, on the left side of the diagram, I have the attacker's machine. On the very right side of the diagram, I have a virtual machine, which is called a EC2 instance, Elastic Compute Cloud instance, in which a company or an organization can run their own code and run their own processes and their workloads. And so that's what's depicted. And to the right is a metadata service. So when services run inside of a virtual machine on a cloud like Amazon, they sometimes need just basic information about themselves, because effectively these virtual machines go up, they come down. It's a very dynamic environment. And so a virtual machine might need to know something as simple as its IP address. And what it can do is it can contact a metadata service to ask basic details like what is its IP address. Now, the metadata service should only respond to services and to virtual machines that are local. And so you'll see this box here to the right in which the metadata service and the virtual machine can communicate with each other. A couple other things about this virtual machine, because it was made publicly accessible on the internet because it needed that to do its job. It was running a web application firewall called Mod Security. Mod Security is a very prevalent, well-known, and heavily used web application firewall that can be used to restrict what traffic is used to communicate with any applications on the virtual machine instance. And so you see that there to the right. In the middle of the diagram at the bottom are the Amazon simple storage service buckets, the S3 buckets that Capital One was using that stored the 100 million credit card applications. And that those buckets, were not configured to be accessible to any and everybody. There was an access control list, an ACL, that specified that the only role, the only user that should be able to access those buckets and the data on the 100 million credit card applications, is a role associated with the web application firewall, which I've denoted here as *** web role. So those are the key components in the anatomy of, the application and the storage that was being used. And let me now chat a little bit about how the attacker conducted the attack. So our attacker, Erratic, she first made a request to the publicly accessible on the internet virtual machine instance that was running one of Capital One's applications, and made a request saying, hey, can you just tell me what security credentials this virtual machine has? And unfortunately, there was a vulnerability inside the application on the virtual machine instance in which it would take requests from users or anybody on the internet, and it would relay that onto the metadata service. And this particular vulnerability is called a server-side request forgery vulnerability. Effectively, the attacker's machine is posing as another server that's placing a request to the virtual machine. And there's a couple of things that are kind of going wrong here. The first thing that's going wrong is the vulnerable virtual machine instance is actually listening, to this request for security credentials. Inside of it, there is a reference to an IP address 169.254.169.254. That is the IP address of the metadata service. And so, there's some parameter that comes over in a URL or an HTTP request that this virtual machine receives. And the first thing it does is it doesn't validate this data. For those of you that are somewhat familiar with security, you know, validating input is a important step that should always be done. And you know, if you don't validate your input, it's kind of like a rookie mistake. So the first thing is that the application running on this virtual machine instance, you know, did not validate the input, because this input is definitely you know, not normal. The second thing that's going wrong here is that the virtual machine instance takes this unvalidated input that came in from the internet and it passes it on to the metadata service. It says, here, metadata service, please, you know, evaluate this request. Somebody has asked what security credentials, you know, this virtual machine instance has, and it sends it on to the metadata service. Now, the poor metadata service is, you know, ends up being what's called a confused deputy here, because the metadata service doesn't know if this request is really coming from the legitimate virtual machine instance that's should be able to access this information, or it doesn't know if it's coming from, you know, some attacker's machine. And so the metadata service, when it gets this request, it just happily does its job and says, oh yeah, you have you know, this web application firewall role, you have security credentials. You have access to the security credentials for the web application firewall. So the vulnerable application on this EC2 instance, you know, then takes the response from the metadata service and sends it back to the attacker's machine. So kind of in step one here of the attack, the attacker was able to ask this vulnerable virtual machine instance what security credentials you have and get a response and find out that it has web application firewall credentials. In the next step of the attack, the attacker then says, you have this, you know, these WAF security credentials. Can you please send the credentials to me? And when the vulnerable virtual machine instance gets the request, because it has this server-side request forgery vulnerability, the exact same thing happens where it you know, doesn't validate the input and who it's coming from and all this other sort of stuff, and it passes the request onto the metadata service. The metadata service, as I mentioned, ends up being a confused deputy in computer science parlance, because it, again, doesn't know who the request is coming from. To the metadata service, it looks like it's coming from the legitimate virtual machine instance that's running one of Capital One's applications. And so it goes ahead and answers it. It says, oh, you would like the security credentials? Here you go. Here's the access ID. Here's the secret key. Here's a token that you can use. You know, should you want to use those security credentials? So the information, because of the SSRF vulnerability, gets relayed to the attacker's machine. And the attacker is really now in business. What the attacker does is takes those credentials and caches them in her AWS command line interface, a shell. You know, for those of you that are familiar with the DOS, it's you know, your command prompt. For those of you that are familiar with Unix, it's your you know, bash or KSH or whatever shell. So pretty much the attacker takes the credentials for the WAF, you know, which should not be accessible to anybody kind of outside of Capital One, and caches it inside of her command line interface so that she can then use those credentials to do other things. So that was the third step in the attack. The fourth step in the attack is she asks the S3 buckets that Capital One has, hey, can you please give me a list of all the buckets, all the storage containers that you have? And so, you know, why should the S3 buckets, why should the storage service listen to the request? Why should it honor it? Well, because the attacker has all the credentials that make it look as if the attacker, you know, kind of is the web application firewall in this case. And so the S3 service happily responds with 700 names of buckets that contain the 100 million credit card applications. After that, pretty much the next step is the game over step. The attacker says, oh, okay, please send me all the data. AWS S3 sync, get me all the data. And, that's what happens. Pretty much this is what resulted in the breach. All the data got sent over to the attacker's home machine running the command line interface that has all the WAF credentials. Now, there's a bunch of things that went wrong here. First of all, one might ask, well, why should the S3 bucket service, why should Capital One's S3 bucket service make the 100 million credit card applications available to even a WAF role, right? A WAF is a web application firewall. It's a piece of security infrastructure that's used to mediate access. But ideally, if you're following the principle of least privilege, then what you should do is configure a role only for applications that actually need to use the data. It's unclear to me as to why the web application firewall, while it is a piece of security infrastructure that does need to mediate access to various services and whatnot, there's no reason that the web application firewall itself, as I understand it, needs actual access to the data. So this breach could have been avoided if perhaps the role that was required could have been more constrained. And then secondly, though there was this server-side request forgery vulnerability in this application running on the EC2 instance, which allowed the attacker to get credentials that only the application should have been able to access. So those are pretty much the two key reasons. But this is how the Capital One breach occurred. So I went through that in a bit more technical detail than the ransomware breach and the public bucket exposure breaches in 2017. But hopefully it gives you a feeling for a little bit more of the technical meat in how this breach occurred. Given that Amazon S3 storage buckets and bucket exposures have been behind so many data exposures and breaches, I thought it might be fun to do an actual example, using Amazon's service here. So if you log into Amazon, and you go to the bucket service, it provides a user interface that looks like this, where you can create buckets. Think of a bucket as a folder. It's just like a directory on a Unix file system or a folder in Windows or on the Mac, and you can create these buckets. So pretty much what I did in this simple example here is I created a bucket called Crazy Test Bucket, and wonderful, it went ahead and it created the Crazy Test Bucket. It says with regards to access, objects within the bucket can be public. This bucket is located in a data center in the U.S. West region in Northern California, and it was created on June 24th. Wonderful. So there's a folder that exists. The next step here that I do is I click into the bucket, and what I did is I uploaded an image into the bucket. So it was similar to the way that a Dropbox or a Box or Google Drive can be used to store files. The Amazon Simple Storage Service, S3, can be used to store files similarly. And you can just go ahead and upload those files, using your Amazon account. And so I uploaded a picture of myself, a headshot. And then I took a next step of taking a look at the access settings for this bucket. And pretty much here, it says that, it gives you an option to block public access, and it says block all public access is off. So let me go ahead and ask a poll question here. Based on what you see in this interface, do you think the Crazy Test Bucket is publicly accessible, or do you think it's privately accessible? I'm going to give you a second to fill out the appropriate radio button, and hit submit. And then in a couple seconds here, we will take a look at the response. And if I can get some info from PAX or anybody on the SPD team, just want to see if people have been able to fill this out.
Yes, Neil, we've got about 50% of the people have answered it. Yeah.
That's great. Thank you, Pax. Good. Okay. Well, very good. So we'll look at the results in just a second here. But if you go ahead and click on the file in the bucket, my headshot here, you can see that I'm the owner. It was last modified. It was a fairly small file. It is protected by server-side encryption by the advanced encryption standard with 256-bit encryption. We chat more about encryption in courses like using cryptography correctly. And there's an interesting object URL here. So basically, once you upload a file to Amazon's S3 service, you can, if things are configured right, you can access them publicly at this URL that they provide. And so not quite sure what you answered, but if you go ahead and click it, then it'll actually bring up my picture when you ask your browser for this URL. Let's see how many people thought the picture was accessible versus not. It turns out that if we go back to the previous slide, it says block all public access off. So what that means is that public access is on. And but you can see kind of the double negative here, but pretty much that's why it was accessible. So let's go to the poll results. We see that 70% of you got it right and understood that the bucket and the headshot was publicly accessible. But almost 30% of you thought it was only privately accessible. And so if we think about that and we look at all the people that might be using Amazon Cloud Services and might be using that user interface, 30% got it wrong. Now, I'm sure Amazon's put a lot of research into this, but part of me wonders, like, if you look at this block all public access off, this is stated as kind of like a double negative. Another way to present this interface should be to say, public access on or off. And, we didn't run the experiment here, but I'm wondering if this was rephrased in that way, if the results might have been a little bit better, and say 30% of folks, even just on this, might have gotten this wrong. Oh, by the way, the poll results changed, so I don't know if people changed their answers or we got more responses. But I think the larger lesson is, you could see how this can be interpreted incorrectly, and how as a result one can have exposures and breaches due to Amazon buckets, say, being inadvertently accessible. And by the way, let me also mention that this is an issue that's not just specific to Amazon. It's with using any cloud service, and it's with any storage that you're potentially making publicly accessible to the internet. It's a very critical thing. There's a very, very big difference between an on or an off here. And by the way, the Amazon interface does allow one to specify much more detailed access policies. But while we're on this topic, let's now, given that the bucket and my headshot was publicly accessible, let's now use the Amazon interfaces to make it private. So what I did is I clicked edit and checked this box here saying block all public access. That seems pretty straightforward. And once I click block all public access, and there's more detailed options here as to if you want to do something more fine-grained. I'm not going to go through all the details here in this particular webinar here, but I click block all public access, I hit save, and the interface tells me, please confirm that's what you want to do. And so I actually have to type the word confirm and hit confirm. And you could imagine that, if you have a significant application that, say, perhaps relying on a lot of data being publicly available, let's say it's like all the images in a social media application, right? Like if you make this private inadvertently, you could basically ruin that functionality and shut off everybody's pictures on their social media profile, like all in one shot. And so, Amazon has no idea like what the scale of the application and what you're trying to do here. And this is why it's asking you to confirm. And I think it asks you to confirm irrespective of whether or not you're blocking access or enabling access. But this is the key idea. After hitting confirm, it says that the public access settings were updated successfully. And we see that it says block all public access on. So what that means is that public access is now disabled. And if we then try to go back to that same URL that I loaded and we were able to see the headshot, now we see that when you try to access the file at that particular URL, it says access denied because the entire bucket is now private. So that was a very short primer in the topic of Amazon S3 buckets and public and private settings. And, we can see that these kinds of settings are just kind of super critical. So now that I've covered a bunch of different cloud breaches that have taken place and covered a simple example of how to make buckets private versus public, let me talk a little bit about some of the things that we'll cover. We are going to be launching a cloud security course this coming fall, as Pax had mentioned. And we've got a lot of interesting topics related to cloud security in mind for the course. So I'm going to sample some of the upcoming content. As Pax mentioned, we did want to gather information on what clouds people are using, what current tools and technologies people are using. We certainly may want to have some coverage of those things, but we also want to have coverage in the course for things that maybe everybody, say, needs to learn more about, or things that are not getting covered in terms of existing tools and technologies are not getting covered as much. We in general want to see the number of breaches go down, and we want to help people get there. So let me chat a little bit about some of the other topics. One of the topics that we're going to be covering in the cloud security course is on cloud compliance and cloud security standards. So as many of you know, there's a lot of different compliance standards out there. I've listed two on this particular slide, GDPR, which is the General Data Protection Regulation that came out of Europe, and the CCPA, the California Privacy Law, that's the kind of like California version of the GDPR. There's some differences and whatnot, but in any case, there's other compliance standards. There's HIPAA, there's SOX, there's PCI, there's a whole bunch of different compliance standards. And, when all these compliance standards were introduced, depending upon which standard it was, for instance, PCI was introduced by Visa and MasterCard to the world in the 2004-2005 timeframes. There was not aggressive use of cloud services at that time. And over the years, there's been more and more of a migration of people moving from on-prem data centers to cloud data centers, and how one achieves compliance with all these standards may need to be a little bit different on the cloud. And so, in our course, what we do is we cover some useful information on how to make sure that your clouds are compliant and achieving various security standards. So if you look at GDPR and CCPA, for instance, both of these standards have some critical aspects to them. One, they require you to track and maintain where personal information is being stored in which locales. Is your data being only stored in data centers in Europe? Is it only being stored in the US? Due to the advent of cloud services, one of the amazing things is you can just change one configuration setting in your cloud configuration, and boom, like Amazon will move all your data from one data center to the other, across the globe. And, if you were to do that with 2 on-premise data centers that your company had to, start and pay for from scratch, that in itself could be a huge project. But basically, one of the advantages of today's cloud services is you could just specify which localities you want your data to be stored as a configuration parameter, and boom, it gets there. It's pretty darn cool. These compliance standards also require you to be able to produce a report on demand of all the personal information that's held. And very importantly, if a particular user, if a consumer, one of your customers, say, comes to you and says, I want you to forget all the information that you have about me. I want you to delete all the PII and personally identifiable information that you have on me. Please do so. You've got to have a way to be able to do that, and do that scalably, because it might not be just one of your customers that ask that. It may be, tens, hundreds, thousands, whatever it happens to be. And you want to be able to give them, allow them to do that in a very easy way. And so in our course, what we'll do is talk about, these different compliance standards, existing compliance standards, and how you can make sure that your cloud configuration accounts for those compliance standards. So as an example, on this slide, we list a number of different requirements that appear in GDPR and CCPA, and some that appear in both. And how do you accomplish that if you're using a cloud in which you're using infrastructure as a service, or IaaS? And one of the important components is to maintain where your user data is being stored, in which localities. And you need to make sure that any access that you give to the data, any privileges that you give to data, is on a need-to-know basis, effectively employing the principle of least privilege. And so, on this next slide, we show some examples. For instance, if you're using the Google Cloud Platform and you're using the command line interface, or CLI, what are the commands that you can use to identify, which region and zones your project is running in, what commands you can use to change, to set the default region and zone. For instance, if you're running in Europe, you may want to tell people in your privacy policy that your data is only stored in the EU. And so you can use a command similar to the second one here on the slide to set that default region. In any case, I think you get the idea, so I don't want to kind of belabor the point here, but data localization is a very important part of achieving some of these compliance standards, and these are the kinds of commands that you can use in the cloud to do them. One other topic that we cover in the cloud security course is the cloud security standards landscape. So while there are many, many, many security standards out there, whether they be PCI or ISO 27000 or GDPR or CCPA, those are fairly general standards. There are a few standards that are coming out that specifically focus on allowing you to assess, the state and how good is your cloud security. And so 3 of them that we'll cover in the course are the NIST Cloud Computers Security Reference Architecture, SP 500-299. There's an organization called the Cloud Security Alliance. They've produced a cloud controls matrix that you can evaluate your cloud security against. And Amazon has a initiative called the Well-Architected Framework. So they have a bunch of domains and areas and a number of things that you can check to see if your use of Amazon is well architected. So these are cloud security standards that we'll be covering in the cloud security course. In any case, to kind of wrap up as we're coming up here near the top of the hour, as you can see, there have been some significant cloud security breaches, whether it be ransomware attacks against MongoDB, whether it be inadvertent S3 bucket exposures, or even more sophisticated attacks as the one that occurred against Capital One, in which it wasn't the case that the S3 bucket, which is completely accessible to the internet as per the example interface that we showed you, but rather it was configured to a particular role, to a particular IAM role, but the problem is that the attacker was able to steal the security credentials for that role. So in any case, given all these types of issues, it's as we showed you, it was really important to make sure you leverage properly the private default bucket settings, and to lock down any legacy buckets that you have. So if while today the default is private for buckets, that perhaps was not the case a few years ago. And so if you have a cloud application that's been running for years, it may be a good idea to go back through all the buckets and make sure you understand, what are the current settings, and further lock them down if needed, so that you don't have a cloud security breach. Then finally, I covered a number of cloud security standards, and I covered what are the kinds of things you need to do to achieve compliance using cloud security centers. As per the fourth bullet, let me come back to the third bullet. In this webinar, we have only really scratched the tip of the iceberg. There are many things that one needs to do in order to make sure that one's use of cloud services is secure. While we've touched on settings for bucket exposures, there's hundreds of configuration parameters. There's a bunch of different cloud security scanners. And I'm not endorsing any particular one, but there's Dome9 and Evident.io and Raleigh Network. There's a lot of different cloud security scanners out there, and cloud firewalls. There's just a lot of tools out there. If you look at the different cloud platforms, they also offer different tools. And so in some of the labs in the cloud security course that we'll be launching this fall, we will cover how you can use some of these tools. But basically, it's important to be able to scan the containers you're using if you're using Kubernetes or Docker. It's important to have denial of service protection. There's recently been in the news, very large, terabyte per second type attacks that have taken place against clouds, and they've stood up, which is great. There's all kinds of encryption key management tools that one can use, on the different platforms. There's features that they have where they can provide logging that can go into your SIEM, your security incident and event management system. Whether it's Splunk or Alien Vault or whatever, right? How do you get logs and data about what's going on in your cloud? So we'll be covering all those topics in the upcoming cloud security course. I hope that you all have learned at least a thing or two about cloud security, perhaps that you didn't know before. Hope you found some of the information about the breaches interesting. Before we finish up here, I just wanted to give thanks to Professor Dan Bonet, one of my colleagues and co-directors of the Stanford Advanced Security Program. Dan provided me with some great feedback and reviews on some of the Capital One diagrams, and we had some good discussions about Convue's deputy. I'd also like to give Andrew Tun props for helping me just show some examples of S3 bucket configurations. Andrew is somebody that used to worked with me on my security team at LifeLock a couple of years ago, and he was just really helpful. So thanks to both Dan and Andrew. With that, I'm going to hand things back over to Pax.
So with that, I'm going to jump to the Q&A. So Neil, we got really a ton of great questions. I thought maybe we could just we could start at a high level. So you've given some very specific examples, but I wonder if you could reflect more broadly on your many years of experience in the security field, how you've seen that landscape changing as more and more services and more companies move to the cloud, and how you see it changing in the future as that trend accelerates.
Sure, I'd be happy to speak to it kind of much more generally. Glad that the specific examples have been appreciated. But to zoom out a bit, I believe that there is considerable promise in how cloud services can be used and leveraged to actually create a more secure environment than was previously possible with, many, and a huge heterogeneity of on-premise data centers. One of the great things about the Amazons and the Google Cloud Platform and Microsoft Azure and whatnot is that they can hire tons of security engineers, much more than can be hired by any particular organization, and they can build more infrastructure, they can build more scanners, they can build more tools that companies can use to secure their use of the cloud. So I think that, as the evolution kind of continues and more services migrate to the cloud, my hope is that, it used to be the case back in the 1920s and whatnot, that, major companies used to hire electrical engineers and keep them on staff in order to keep the electricity coming in. And what we saw over time was that, most of the electrical engineers got hired by the power companies, and then even big companies just relied on the power companies as a utility in order to keep the electricity coming in and operating safely. And I think that with cloud services, there is that opportunity that the big cloud platforms can become kind of like the power company, right? Where they can hire, a good number of security engineers. So each company doesn't have to. Everyone maybe need to hire, fewer, maybe a couple. But you can take advantage of all the infrastructure and all the scanning and all the tools provided by the cloud providers. To an extent, if you can get security right in just a few of the big clouds and everybody leverages that, there's an opportunity. Now, it may take some time to get there, and there have been cloud breaches, but I think there is huge hope and promise talking about it more generally.
Thanks, Neil. I think the two nice questions that are good follow-ups on that one. So the first is you've talked a lot about infrastructure as a service, but more and more people are also using platforms as a service or software as a service. Does that introduce similar security risks, and how should engineers and companies be assessing or thinking about those risks?
So that's a good question. I think that whether you're using infrastructure as a service, platform as a service, software as a service, with each of those, you're relegating kind of more and more of the security. You could be relegating more and more of the security to the cloud provider, effectively. I'm sorry, let me take that again. With infrastructure as a service, if you're using the infrastructure as a service, you actually have to worry more about security than with PaaS or SaaS. I think that as you move from infrastructure as a service to platform as a service to software as a service, there can be kind of less that you need to worry about, because the cloud provider then has to worry about the security of the infrastructure, the security of the platform. Even with SaaS, though, you have to worry about the security of the application. You're still going to need to worry about making sure that your application is not vulnerable to, say, a server-side request forgery attack, as happened with the Capital One. So I think that there's some advantages to leveraging more and more of the services provided by the clouds and kind of going up the stack, but you're still going to need to leverage best practices. So for instance, in the case of application security, if you just want to do SaaS, you still may want to consider using static analysis to look for vulnerabilities in your application at compile time. You still want to leverage using DAST or using dynamic scanning while your application is running to look for vulnerabilities. You may want to consider using RASP protections, runtime protections, in which there's an agent in your software where it's looking for attacks, kind of online in real time as it's running in production. There have been, pros and cons of each of these, but I believe that all of those typical application security best practices, you should still probably, do code reviews when needed. You should, actually try to shift left as much as possible, find as many issues of things in the design stage as much as possible. So anyhow, those are just some comments on best practices.
Thanks, Neil. We're at time, so I want to be respectful of both your time and everyone who's joined us. Far more questions than we could possibly answer right now. But again, please keep them coming. We are collecting them. It'll give us insight as we further develop the course. Neil, I wanted to thank you for your time and the excellent presentation. A lot of really positive feedback. People were very excited and appreciative of the specific examples. And I want to thank everybody who joined us today for participating and posting your questions and participating in the polls. So we look forward. We are trying to Neil coming up in August. So we hope something on the cybersecurity professional. So if that's something you're interested in, please keep an eye out. And in addition, if you're interested in the cloud security course, please let us know. And you've answered the poll, so we'll reach out to you if you expressed interest, and we will be in touch. So thank you, Neil. Thank you, everyone.
Great. Thank you, Pax. And thanks, everybody, for joining today.